Imagine the grit of sand under your fingernails, the ache in your back that never truly leaves, the rhythmic thud of a hammer against stone, day after day, year after year. Now, picture that singular, exhausting effort multiplied by millions of hands over centuries, across a landscape so vast it stitches together mountains and deserts. That relentless, silent dedication, brick by single heavy brick, forged something that utterly defies belief. Welcome back, everyone. Today we're not just looking at a wonder of the world. We're rediving into the very heartbeat of its creation, the endless brickwork of the Great Wall of China. And I guarantee, by the end of this journey, you'll never look at this ancient marvel, or indeed any monumental human endeavor, the same way again. If you find yourself drawn to the quiet power of human will and the stories etched in stone, do me a favor and hit that subscribe button. We uncover incredible tales of perseverance every single week, and you won't want to miss the next one. So settle in, take a deep breath, and let's begin to feel the rhythm of an empire being built. And so, we begin to feel the rhythm of an empire being built. But before a single brick could be laid, before the mortar could be mixed, before the great sentinel stood guard, there was a far more fundamental challenge. Where did ITEL come from? The sheer, incomprehensible mass of the Great Wall, stretching thousands of miles across the rugged spine of ancient China, demands an answer to this first, most colossal question. How do you source the stone? How do you move mountains, figuratively and literally, to build another mountain? Imagine for a moment standing at the base of a towering, unyielding peak, its jagged face scarred by millennia of wind and rain. This isn't just a picturesque landscape. It's the raw material for an entire civilization's ambition. The Great Wall, in its myriad forms and sections, didn't emerge from a single, uniform quarry. Oh no, its very fabric is a testament to the incredible diversity off the land it traverses. From the granite and limestone of the eastern sections near Beijing, robust and enduring, to the softer loess and sun-baked earth bricks used in the more arid western stretches, the wall is a geological tapestry. Each region presented its own challenges, its own opportunities, its own unique contributions to the colossal undertaking. Let's begin in the heart of the northern provinces, where the wall often hugs the contours of formidable mountain ranges. Here, the primary building blocks were found right beneath their feet, or rather carved from the very mountainsides they sought to fortify. Granite, known for its incredible hardness and resistance to erosion, was a prized commodity. Limestone, while slightly softer, offered a practical alternative, especially when closer to the construction sites, and could be dressed and shaped with less arduous effort. Slate and various types of sandstone also played their part, chosen for their local abundance and structural suitability. But finding suitable rock was merely the first whisper of an impossibly long journey. The true ordeal began with extracting these colossal pieces from their ancient slumber within the earth. Picture a quarry from 2 millennia ago, not the mechanized, roaring operations of today, but a landscape minuted by the raw power of human muscle and the ingenious application of basic physics. The scene would have been a constant symphony of human effort. The air, thick with dust, and the tang of freshly broken rock would have hummed with the rhythmic clang of iron against stone, the grunts of exertion, and the shouted commands of overseers. Thousands of men, often conscripted farmers, soldiers, or even convicts, toiled under the unforgiving sun or in the bitter cold, their lives measured in cubic feet of extracted stone.
Ow.
The initial task was identification. Experienced prospectors, often with generations of local knowledge, would survey the mountain faces, looking for natural fault lines, cracks, or areas where the rock seemed amenablato splitting. They understood the subtle language of the earth, discerning where a vein of granite ran true or where a limestone deposit offered the desired quality. Once a suitable site was chosen, the work began with a primitive but effective toolkit. Iron chisels, heavy hammers, wooden mallets, and an array of wedges were the bedrock of their extraction techniques. One of the primary methods for detaching large blocks involved a technique often referred to as wedge and feather. Imagine a line of men, each armed with a heavy hammer and a sturdy iron chisel, systematically hammering small, precise holes into the face of the rock. These holes, perhaps a foot or so apart, would follow a natural fracture line or a deliberately marked path. Once the holes were drilled to a sufficient depth, dry wooden wedges would be carefully inserted into each one, Then, the real magic, a testament to ancient ingenuity, would begin. Water, precious and often scarce, would be poured over these wooden wedges. Slowly, inexorably, the dry wood would begin to absorb the moisture, swelling with an irresistible force. The expansion, though imperceptible at first, would build immense pressure within the rock. A low, grinding groan might precede it, or perhaps a sudden, sharp crack as the mountains surrendered a massive, newly formed block. It was a slow, deliberate process, demanding patience, precision, and an understanding of the immense, silent power of nature. Another more dramatic method, particularly effective for stubborn, massive formations, was the use of fire and water. Imagine the sheer spectacle of it. Massive bonfires built directly against the rock face. Roaring flames licking at the stone for hours, sometimes even days. The intense heat would cause these outer layers of the rock to expand. Then, at a precise moment, perhaps with a synchronized shout, torrents of cold water would be thrown onto the superheated surface. The sudden, drastic temperature change would induce thermal shock, causing the rock to contract rapidly and violently, creating deep fractures and fissures. The air would hiss with steam, thick with smoke, and the ground might even tremble as great sections of the mountain groaned and cracked. It was a dangerous, volatile method, yet immensely effective in breaking down otherwise intractable geological formations. Once a large section of rock was detached, the challenge shifted to breaking it down into manageable blocks. This was the domain of the skilled stonemasons, whose expertise was vital even in these early stages. Using smaller chisels and hammers, they would meticulously work along natural cleavage lines, splitting the larger masses into more uniform pieces. The goal wasn't perfect precision at this stage, but rather to reduce the bulk and weight, making the blocks easier to transport. The sounds in the quarry would evolve from the deep, resonant thud of breaking rock to the higher-pitched, almost musical chime of chisel against stone, a steady, relentless rhythm of shaping. The dangers were omnipresent. Rock falls were a constant threat, and the sheer physical toll of swinging heavy tools, breathing dust-laden air, and working under extreme conditions led to countless injuries, debilitating illnesses, and often death. For every meticulous block that made its way to the wall, there was an unseen story of human struggle, sacrifice, and often tragedy etched into the very soil of the quarry. With the raw stone extracted and roughly shaped, the next monumental hurdle presented itself: how to move these colossal blocks weighing hundreds, even thousands of pounds, from the remote quarry sites to the actual construction line, often many miles away, over some of the most unforgiving terrain imaginable. This, perhaps more than any other stage, embodies the sheer, indomitable will of the ancient Chinese builders. The primary method of transportation, particularly in the mountainous regions, was brute human force. Imagine lines of hundreds, sometimes thousands of laborers, their backs straining, muscles taut, chests heaving as they pulled enormous sledges laden with stone. These sledges were often simple wooden platforms, sometimes reinforced with metal, designed to slide over the ground. Ropes, thick and woven from hemp or bamboo, would be attached, forming a vast network of human sinew and will. Where possible, paths would be leveled, and in some areas, the ground would be intentionally made slippery with water or mud to reduce friction. Every inch of progress was hard-won, a testament to synchronized effort and an almost hypnotic rhythm of strain and release. For uphill climbs, the process was agonizingly slow. Each step required immense effort, the sledges digging into the earth, demanding even more from the human engines pulling them. Supervisors, often with whips or shouts, would maintain the relentless pace. For descents, the danger shifted. Controlling the momentum of a runaway stone block down a steep incline was perilous work, requiring immense strength, coordination, and often strategically placed ropes and levers to act as brakes. The sound of a heavy sledge groaning over uneven ground, the creak of stressed ropes, the unified grunts of men would echo through the valleys, a constant low thrum of monumental labor. Where the terrain allowed, especially on flatter or gently sloping ground, rollers came into play. These were often stout tree trunks, kudo-size and placed beneath the stone block. As the stone was pushed or pulled forward, the rollers would be retrieved from behind and placed at the front, creating a continuous slow-motion conveyor belt. This method still required immense human effort to overcome inertia and maintain momentum, but it distributed the load somewhat more efficiently than pure dragging. Animal power, primarily oxen, was also utilized, particularly for larger, more manageable blocks or for pulling carts over relatively smoother terrain. However, the mountainous nature of much of the wall's route, combined with the difficulty of providing fodder and water for large numbers of animals in remote areas, meant that human labor remained the dominant force. An ox could pull more than a man, but an army of men could pull almost anything. The ingenuity of these ancient engineers truly shone in their use of rudimentary mechanical advantage. Simple leverage systems, employing long, strong timbers as fulcrums and levers, allowed a few men to lift or shift incredibly heavy stones, inch by painful inch. Earth and timber ramps were constantly constructed and dismantled, built up to the height of the nascent wall section, allowing stones to be pulled or rolled into place. These ramps represented a dynamic, ever-changing landscape around the wall, a temporary earthwork that mirrored the permanent stone structure it helped create. Pulleys, though perhaps not as sophisticated as those developed in later centuries, would have been employed in basic forms to assist with lifting in specific, challenging situations. The terrain itself was a formidable adversary. The wall in its strategic brilliance often followed the highest ridges and the most precipitous mountain passes. This meant that the paths from quarry to construction site were rarely straightforward. They traversed steep inclines, navigated narrow ravines, crossed rushing rivers, and wound their way through dense forests. Each obstacle demanded a unique solution, a new feat of engineering, or a renewed application of sheer, unadulterated human grit. River crossings, for instance, introduced an entirely new set of logistical nightmares. Where rivers were shallow enough, temporary causeways of stone and timber might be constructed. For wider, deeper waterways, massive rafts, fashioned from logs and often lashed together with incredible strength, would have been deployed. Imagine the effort of loading these immense stone blocks onto a precarious raft, guiding it across a powerful current, and then unloading it on the far bank, all without the aid of modern cranes or machinery. It was a perilous dance between human will and the indifferent force of nature. And then there was the sheer distance. Many quarries were not conveniently located next to the wall. The journey from extraction point to final placement could stretch for days, weeks, even months, depending on the region and the scale of the task. This required an immense logistical and administrative effort, one that speaks to the highly organized, if brutal, nature of the imperial machine. Military oversight was common, with soldiers and their commanders tasked with managing the vast workforce and ensuring the continuous flow of materials. Skilled supervisors are caxmaxts, master masons, and local leaders with an understanding of the terrain would direct the operations, ensuring that the supply chain, however rudimentary, remained unbroken. Temporary camps, often little more than clusters of crude shelters, would spring up near quarries and along major transportation routes. These were harsh, Spartan environments, providing minimal respite from the grueling labor. Food and water, themselves precious commodities, had to be transported to these remote locations, adding another layer of complexity to the supply lines. Maintaining the health and morale of such a massive, dispersed workforce was a constant, draining challenge. Disease was rampant, accidents frequent, and exhaustion a constant companion. The human cost of sourcing and transporting the stone is almost impossible to quantify. While popular legends sometimes speak of bodies literally being buried within the wall, providing a macabre cement, the reality was perhaps even more tragically prosaic. The ground around the wall, near the quarry sites, and along the treacherous transport paths, would have been the true testament to the lives lost. Cement perished from accidents, rock falls, crushing injuries, falls from heights, drownings during river crossings. They succumbed to disease, exacerbated by poor sanitation, inadequate nutrition, and relentless physical strain. Exposure to the elements, from the searing summer heat to the bitter winter winds, claimed countless others. Forced labor, a significant component of the workforce, meant that these individuals had little choice but to endure. Families were separated, lives uprooted, and the prospect of escape was met with brutal punishment. The motivation to continue, for many, was simply survival. A grim determination to see another dawn, to escape the whip, to earn a meager ration for another day. It was a testament to the unyielding progress not just of stone, but of human resilience, driven by the command of an empire that demanded its will be etched into the very landscape. As we look at the Great Wall today, its weathered stones standing sentinel across the centuries, remember the unseen mountains from which they came. Remember the clang of the chisel, the groan of the sledge, the grunts of 1,000 men pulling in unison. Remember the smoke and steam of the fire-split rock, and the silent, unyielding patience of wood swelling with water. Each block, each dressed stone, each roughly hewn piece, carries not only the geological history of its origin, but also the indelible imprint of human hands, human sweat, and human sacrifice. The enduring presence of these mountains, reshaped an empire's will, continues to speak to us today, a silent, monumental symphony of labor and stone. We have spoken of the mountains, of the stone wrested from the earth, and of the countless lives given over to its journey. But what good is a mountain of stone, however meticulously cut and moved, without the vital bond that unites it, without the patient, almost alchemical, creation of the substance that would hold an empire's will? Brick by brick, against the relentless march of time and elements. This brings us to a less celebrated, yet utterly foundational aspect of the Great Wall's construction, the art of mortar mixing. It was a foundation built not just of material, but of immense patience. Imagine, if you will, the sheer scale of such an undertaking. It's not merely laying one brick upon another, but binding millions upon millions of bricks and stones across thousands of miles. The mortar, this unassuming paste, was the silent, tireless glue that transformed disparate elements into a singular, colossal structure. It was the crucial intermediary, the liquid bridge between solid rock and its preparation was a craft as demanding, in its own way, as the quarrying of the stone itself. In the earliest iterations of the wall, and in some of its more rudimentary sections, the binding agents were often as simple as the earth beneath the builder's feet. We find evidence of sections where compacted earth, clay, or even a basic mud mixture served as the rudimentary mortar. These methods, while expedient, offered little in the way of long-term durability. Often washing away with the rains or crumbling with the passage of seasons, these initial endeavors, though monumental in their ambition, often lacked the enduring strength that would become the hallmark of the Great Wall we recognize today. They were the first whispers of a grand vision, constrained by the materials and knowledge of their time, offering but a fragile barrier against the vastness of the northern steppes. But as the empire's ambitions grew, so too did its understanding of construction. The quest for permanence, for a wall that would truly defy time, led to a profound innovation: the use of lime mortar. This was a technological leap, a sophisticated development that elevated the Great Wall from a mere earthen barrier to an unyielding fortress of stone. The journey of lime began, much like the stone it would bind, deep within the earth. The primary ingredient for lime is limestone, a sedimentary rock composed primarily of calcium carbonate. This humble stone, abundant in many regions, had to be identified, quarried, and transported. While perhaps less arduous than hauling massive granite blocks, the continuous demand for limestone meant an ongoing effort. With dedicated teams excavating deposits in proximity to the construction sites, the limestone quarries, often less dramatic than their granite counterparts, were nonetheless vital arteries feeding the colossal project. Once extracted, the limestone underwent a transformative process known as calcination, or more simply, burning. This was where the true alchemy began, requiring specialized stress kilns. Picture these ancient kilns, often dug into hillsides or built as sturdy, beehive-shaped structures of brick and stone. They were not merely bonfires, but carefully designed ovens, capable of sustaining intense heat for prolonged periods. Into these kilns, the quarried limestone was loaded, layer upon layer, alongside immense quantities of fuel. Wood, often from deforested areas, and charcoal, meticulously produced, would be fed continuously into the roaring fires below limestone. The heat within these kilns was immense, reaching temperatures of around 850 to 1000 degrees Celsius. A glow of incandescent orange visible even in daylight, casting flickering shadows as the sun set. This inferno was maintained not for hours, but for days, sometimes even weeks, a testament to the ceaseless labor of the kiln workers. Their task was arduous, dangerous, and demanding. They had to constantly monitor the fires, ensuring a consistent temperature, preventing collapse, and enduring the suffocating heat and smoke. It was a dance with fire, a careful balance between intense heat and precise timing. Within this fiery embrace, a remarkable chemical transformation occurred. The calcium carbonate off at limestone would shed its carbon dioxide, leaving behind a highly reactive substance known as quicklime, or calcium oxide. When the fires finally died down and the kilns cooled enough for access, what emerged was no longer dense rock, but a lighter, more porous, and incredibly potent material. This quicklime, stark white and powdery, was the raw power of the mortar, a substance eager to react, ready for its next stage of transformation. The next step, slaking, was arguably the most dramatic and dangerous part of the entire process. Quicklime, freshly extracted from the kiln, was not yet ready for mortar. It had to be slaked, combined with water. This was not a gentle mixing, but a violent, exothermic reaction. Imagine large, shallow pits or robust wooden troughs, specifically prepared for this purpose. The quicklime, often still warm from the kilns, would be carefully shoveled into these receptacles. Then, slowly, cautiously, water would be added. The moment water touched quicklime, the reaction was immediate and intense. A furious hiss would erupt, followed by plumes of thick, choking steam. The mixture would boil and bubble ferociously, generating immense heat, often reaching temperatures high enough to scald or burn. The quicklime would swell, crack, and crumble, transforming from solid lumps into a creamy white paste. This process required immense caution. Workers, their faces often swaddled to protect against the caustic dust and scalding steam, would use long-handled tools to stir the mixture, ensuring all the quicklime was thoroughly hydrated. The air would be thick with the acrid smell of thallium, a constant reminder of its reactive power. This bubbling, steaming cauldron was the birth of slaked lime, or calcium hydroxide too, the essential binder that would give the mortar its strength and workability. Once fully slaked, the lime paste was often left to mature for a period, sometimes weeks or even months, allowing it to achieve optimal consistency and reactivity, much like a fine wine allowed to age. While lime mortar was a significant advent, the ingenious stroke that elevated the Great Wall's resilience to legendary status, involved an unexpected, yet utterly vital ingredient. Sticky rice. Yes, the very staple that fed millions across China, became a cornerstone, quite literally, of its most iconic structure. This wasn't just a casual addition. It was a deliberate, highly effective engineering choice. The discovery of sticky rice as a mortar additive is shrouded in the mists of time, likely emerging from centuries of empirical observation and accidental discovery. Perhaps a builder, in a moment of necessity or experimentation, added some leftover glutinous rice gruel to a lime mix and observed its superior adhesive qualities. Whatever its origin, the practice began with esprit, particularly during the Ming Dynasty, when many of the most durable sections of the Great Wall were constructed or rebuilt. The science behind this ancient innovation is fascinating. Sticky rice, particularly varieties rich in amylopectin, a branched-chain starch, possesses remarkable binding properties. When cooked and mashed, the amylopectin forms a highly viscous, sticky paste. When incorporated into lime mortar, this organic polymer acts as a powerful reinforcing agent. It improves the mortar's workability, making it smoother and easier to apply, but more importantly, significantly enhances its strength, elasticity, and water resistance. The sticky rice essentially creates a composite material where the organic polymers interweave with the inorganic lime, forming a matrix that is both tough and flexible. It was, in essence, an early form of organic and organic composite material, a testament to the sophisticated practical knowledge of ancient Chinese builders. The preparation of sticky rice for mortar was itself a significant undertaking. This wasn't just a handful of leftover grains, it was a mass production effort. Fields had to be cultivated, harvested, and the rice processed. Then imagine immense cauldrons, perhaps resembling those used for communal cooking, where vast quantities of sticky rice were boiled until soft and glutinous. Following cooking, the rice would be thoroughly mashed into a thick, homogeneous paste. This was no quick task, demanded considerable effort to achieve the desired consistency. A uniformly sticky and pliable mass, free of lumps, ready to be introduced into the lime mix. The sweet, earthy smell of cooking rice would mingle with the acrid temps of lime. A unique olfactory signature of a construction site dedicated to longevity.
Oh my.
With the slaked lime paste and the sticky rice paste ready. The stage was set for the final, crucial step. The mixing of the mortar. This was a communal, rhythmic activity, often taking place in large purpose-built pits or in expansive, hardened earth platforms near the construction sections. The basic recipe for this exceptional mortar typically involved three main components: the slaked lime paste, suitable aggregate, and of course the sticky rice paste, all bound together with water. The aggregate, often coarse sand or finely crushed rock, played a vital role. It added bulk to the mortar, preventing excessive shrinkage and cracking as it dried, and provided structural integrity, acting as tiny internal bones within the binding matrix. The quality of the sand was critical. It needed to be clean, free of organic impurities, and possess a good range of particle sizes to ensure optimal packing and strength. Sourcing this sand, often from riverbeds or designated pits, added another layer of logistical complexity to the builder's challenges. The mixing process itself was a marvel of manual labor and practiced coordination. Workers, often in teams, would shovel the slaked lime, sand, and sticky rice paste into the mixing pit. Then, with long-handled hoes or shovels, they would begin the arduous task of turning and blending the ingredients. This was not a quick stir. It was a methodical, repetitive process, a rhythmic dance of human effort. The goal was to achieve a perfectly homogeneous mixture, where every particle of sand was coated, every trace of rice paste integrated, and the entire mass reached the ideal consistency. Imagine the sounds: the scrape of shovels, the rhythmic thud of hoes hitting the sticky mixture, the grunts and murmurs of the laborers. The consistency was paramount. To wet, and the mortar would be weak and difficult to work with, prone to excessive shrinkage. To dry, and it would be crumbly, unable to adhere properly, and difficult to spread. The experienced foremen, the master mixers, would know by touch, by sight, by the very feel of the resistance against their tools, when the mortar was just right. It was a visceral, tactile knowledge passed down through generations, an art perfected not in textbooks, but through endless hours of physical exertion under the sun and wind. Sometimes animals might have been employed to aid in this mixing, particularly for larger batches. Oxen or donkeys, harnessed to a central pole, might walk in circles, dragging a heavy beam or stone through the mixture, slowly grinding and blending it. This would have been a labor-saving, thoughtful, time-consuming method for massive construction efforts. But whether by animal or by pure human muscle, the outcome had to be the same: a perfectly mixed, uniform, and powerfully adhesive mortar. The logistics of mortar production were staggering. Consider the continuous, immense demand for water, essential for both slaking the lime and mixing the mortar. In arid regions or at high altitudes, where many sections of the wall were built, obtaining and transporting water was a monumental challenge in itself, requiring dedicated teams of water carriers and ingenious systems of collection and storage. Every drop was precious, every bucket a testament to relentless effort. Then there was the sheer scale of the workforce dedicated to this one aspect of construction. It wasn't just masons laying the stones. Behind them, supporting them, was a vast network of individuals. The limestone quarrymen, kiln operators enduring the heat, the slakers braving the steam and caustic reactions, the rice growers and cooks, the sand gatherers, the water carriers, and the countless mixers, all working in unison, a continuous supply chain feeding the insatiable maw of the Great Wall. The continuous flow of materials, on the raw earth to the finished paste, had to be meticulously managed. coordinated across vast distances and challenging terrains. Any bottleneck, any delay in the supply of one component could bring construction to a halt. The profound impact of this carefully prepared mortar on the wall's durability cannot be overstated. It was far more than just a filler between stones. It was the crucial element that transformed a pile of rocks into an integrated monolithic structure. The mortar filled every crevice, preventing water from seeping in and initiating the destructive rethaw. Cycles that would otherwise crack and shatter the masonry. It distributed the immense loads from the stones above evenly, preventing localized stress points that could lead to collapse. And, crucially, the sticky rice additive granted it extraordinary tensile strength and flexibility, allowing the wall to resist minor movements and settlements without fracturing, offering an astonishing resilience against earthquakes and the slow, inexorable forces of nature. Today, as we stand before sections of the Great Wall, particularly those from the Ming Dynasty, the enduring strength of this ancient mortar is palpable. In many places, the mortar joints remain incredibly hard. Often even more resilient than the weathered stones or bricks they bind, attempts to remove a brick from such sections reveal the stubborn, almost unbreakably grip of the sticky rice mortar, a testament to the foresight and ingenuity of its creators. It is a material that has outlasted empires, defied centuries of erosion, and continues to hold true. This entire process, from the sourcing off limestone to the final rhythmic mixing, embodies the very essence of patience that underpins the construction of the Great Wall. There were no shortcuts, no quick fixes. Each stage demanded careful execution, a deep understanding of natural processes, and annual commitment to quality. The ancient builders weren't just mixing ingredients. They were crafting endurance, forging longevity, laying a foundation of patience into every batch of mortar. In an age of instant gratification, where materials are engineered in laboratories with precise chemical formulas, the resourcefulness of these ancient builders is all the more remarkable. With relatively simple tools and a profound intuitive grasp of material science, they created a binding agent that rivaled, and in some respects surpassed many modern equivalents in its context. They understood that the strength of their wall lay not just in the imposing size of its stones, but in the unseen, humble, yet powerfully effective paste that held them all together. The art of mortar mixing was a silent symphony of labor, knowledge, and enduring patience, a foundation upon which an empire built its most enduring legacy. The perfect consistency of mortar, achieved through careful selection and tireless mixing, was not an end in itself, but rather the essential precursor to the next critical stage of the wall's construction: the patient, rhythmic laying of brick upon brick, course upon course. Imagine the vast stretches of the wall, not as a single monolithic structure, but as a mosaic of countless individual decisions, each a testament to the skill and perseverance of the ancient builders. It was here, in the precise placement of each stone and brick, that the art of masonry truly found its expression, transforming raw materials into an unyielding shield. With the mortar ready, a glistening, slightly gritty paste, sometimes pale gray, sometimes warm ochre, depending on the local soil and lime. The stage was set for the masons. These were the maestros of the wall, their hands calloused, their eyes sharp, their movements practiced through years, perhaps even generations, of apprenticeship and labor. They understood the language of stone and clay, the subtle give of fresh mortar, the precise angle required for an unyielding bond. Their craft was not merely about stacking, it was about creating a cohesive, enduring whole from disparate parts, a silent conversation between human will and the stubborn resistance of nature. The rhythm of bricklaying began with the preparation of the immediate work area. Before any brick could be laid, the ground had to be carefully prepared and leveled, a task often undertaken by ground crews before the masons arrived. For the lower courses, especially in sections where the wall met the natural terrain, massive foundation stones were first carefully set into place, often partially embedded in the earth. These initial stones were painstakingly chosen for their stability and size, serving as the immutable bedrock upon which the rest of the structure would rise. Their placement required not only immense physical strength, but also an acute understanding of load distribution and geological stability. Each foundation stone was a miniature architectural project in itself, needing to be seated perfectly, providing a solid, unmoving base against the inevitable shifts of the earth. Once the foundation was established, the masons would begin the painstaking work of laying the first course. This was perhaps the most crucial stage, for any imperfection here would ripple upwards, potentially compromising the integrity of the entire structure. A master mason, or a highly skilled foreman, would typically supervise this initial layout. They would use simple yet profoundly effective tools to ensure absolute precision. The most fundamental among these was the plumb bob, a small, weighted object suspended from a string. By holding the string taut, the plumb bob would indicate a perfectly vertical line. It's an indispensable guide for establishing the true, upright face of the wall. For horizontal accuracy, straight edges, often long, smooth planks of wood, were employed in conjunction with levels. Early forms of levels might have involved a simple water-filled trough or a spirit level, if available, but often it was a matter of experience, aids, and careful measurement against a known reference point. The first layer of mortar was spread, not too thick, not too thin, forming a consistent bed upon which the initial bricks or cut stones would rest. This bed mortar needed to be even, without air pockets, of uniform thickness, to ensure that the weight of the subsequent courses would be evenly distributed. The mason would use their trowel, a tool that was an extension of their hand, often made of iron or hardened wood, to scoop and spread the sticky, gray paste. With swift, practiced movements, they would lay down a continuous line of mortar, smoothing it out with the flat of the trowel, sometimes creating a slight furrow in the center to help displace air when the brick was placed. Then came the placement of the brick itself. Each brick or stone was carefully selected for its fit and placed onto the fresh mortar. The mason would typically tap it gently with the handle of their troweler, a small wooden mallet, settling it firmly into the bed. This tapping was not just to secure the brick, but also to ensure that the mortar completely filled any voids beneath it, creating a full and robust bond. The goal was to achieve what is known as full bedding, where the entire bottom surface of the brick or stone was in contact with mortar, maximizing the surface area for adhesion and distributing the load evenly. As the brick was set, any excess mortar squeezing out from sides was carefully scraped away with the edge of the trowel, to be reused or discarded, ensuring a neat and clean joint. The journey of the brick, from its creation in a distant kiln or its shaping in a quarry, to its final resting place in the wall, was a logistical marvel in itself. Millions upon millions of bricks and stones had to be moved, often over treacherous terrain, sometimes hundreds of kilometers. While the sourcing and shaping were distinct processes, the immediate availability of materials at the construction front was paramount to maintaining the rhythm of bricklaying. Teams of laborers, often carrying heavy loads on their backs, or utilizing simple handcarts, sleds, and even specialized rope and pulley systems on steeper inclines, brought the raw components right to the mason's feet. Imagine the unending procession, a human chain stretching back from the wall. Each person a link in the supply line, ensuring that the masons never had to pause their meticulous work due to lack of materials. This constant flow was vital. Any interruption would break the carefully orchestrated rhythm, causing delays and dampening morale. As the first course was laid, the masons would meticulously check for straightness and level. This was often done using a string line, stretched taut between two line pins or stakes driven into the previously laid courses at either end of a section. This simple yet incredibly effective guide allowed masons to lay subsequent bricks in a perfectly straight line, maintaining the uniform width and alignment of the wall's face. The string line became the horizontal horizon for the mason, a constant reference point that guided their hands and eyes. Once the first course was complete, the process would repeat, layer upon layer, but with an added element of structural integrity, bonding patterns. Ancient builders, through centuries of experience, understood that simply stacking bricks directly on top of each other would create weak vertical joints, susceptible to cracking and collapse. Instead, they employed various bonding techniques, the most common of which involved staggering the vertical joints between successive courses. This meant that a vertical joint in one course would be offset, or broken by the solid body of a brick in the course above and below it. This interlocking mechanism distributed the load more effectively, preventing long, continuous lines of weakness and significantly enhancing the structural stability of the entire wall.
Different dynasties and regions along the Great Wall utilized various bonding patterns, reflecting local traditions and Sometimes, large, rectangular cut stones would be used for the outer faces, with smaller rubble infill, and the stone would be laid in a stretcher bond, where the long side of the stone faced outwards. Other sections, particularly during Ming Dynasty, heavily relied on baked bricks, which allowed for a more uniform and refined construction. Here, bonds like the English bond or Flemish bond might be subtly referenced, even if not strictly adhered to in the classical European sense. The Eastern sermon, the same, to overlap and interlock, making each course dependent on and reinforced by its neighbors. The application of mortars was not just for the horizontal bed joints, but also for the vertical head joints, the space between the ends of adjacent bricks in the same course. As a brick was about to be placed, the mason would typically butter one end with a scoop of mortar, ensuring that when the next brick was pushed against it, a full bond was achieved. This required a delicate touch, enough mortar to fill the joint completely without excessive squeezing out, which would waste precious material and require additional cleaning. The consistent thickness of these head joints was just as important as the bed joints in maintaining the overall structural integrity and aesthetic of the wall. As the wall rose, the masons would typically work in lifts or sections, allowing the lower courses to gain some initial strength before more weight was added. This was particularly important with the slower-setting sticky rice mortar, which needed time to cure and achieve its full adhesive power. The speed of construction was thus dictated not just by the pace of laying, but by the natural processes of material curing. This built-in patience was a fundamental aspect of the wall's longevity. The entire process was accompanied by a unique symphony of sounds. The gentle scrape of the trowel on mortar, the soft thud of a brick settling into place, the tap of a mallet, the hushed commands passed between masons and their assistants. There would be the rhythmic creak of ropes and pulleys, the grunt of men straining with heavy loads, the distant clatter of stones being shaped. And beneath it all, pinless, almost hypnotic drone of thousands of lives engaged in a singular, monumental task. This soundscape, repeated for centuries, became an auditory signature of the wall's growth, a testament to the unyielding human effort etched into its very fabric. The human element was undeniably central to this rhythm. Imagine the thousands of hands, each contributing to this gargantuan endeavor. There were master masons, whose expertise was invaluable, guiding the younger, less experienced hands. There were apprentices, learning trade through observation and repetitive tasks, gradually honing their skills. And there were countless laborers, often conscripted soldiers, peasants, or even prisoners, whose physical strength was harnessed for the heavier lifting and repetitive movements. The physical toll was immense, working under the scorching sun or in bitter winds, often with inadequate food and rest. Yet, for many, there was also a profound sense of shared purpose, a collective effort towards a goal that transcended individual lives. The wall was not just a defensive barrier. It was a living monument built by the combined will and suffering of generations. Building the Great Wall was not a uniform process across flat, easy terrain. Instead, it snaked its way across some of the most challenging lands imaginable. Soaring mountain ridges, deep valleys, and unforgiving deserts. This meant that the rhythm of bricklaying had to constantly adapt to the natural contours of the land on steep slopes, instead of building vertically. The wall often ascended in a series of steps or ramps with the bricks laid to follow the gradient. This required masons to adjust their techniques, sometimes even tilting the mortar bed slightly to ensure the bricks remained secure and aligned with the intended angle of the ascent. In valleys, where foundations had to be dug deeper to find stable ground, or where the wall had to cross rivers, sophisticated engineering solutions like arched bridges or fortified culverts were integrated, each requiring specialized masonry techniques and an even greater degree of precision. The weather, too, played an unceasing role in dictating the pace and methods of construction. In the searing heat of summer, mortar would dry and cure much faster. requiring masons to work quickly and perhaps keep the fresh mortar shaded to prevent premature drying. In the bitter cold of winter, construction would often slow or halt entirely, as water in the mortar would freeze, compromising its strength and bond. Working in driving rain or high winds added further challenges, making it difficult to maintain straight lines, keep mortars consistent, and ensure workers' safety. The resilience of the builders extended not just to their physical endurance, but also to their ability to adapt their methods to the relentless caprices of nature. Understanding that rushing the process in adverse conditions would only lead to a weaker structure.
Quality control was paramount. Foremen and overseers, often equipped with plans or detailed instructions from architects and military strategists, constantly inspected the work. They would check the plumb of the walls, the straightness of the courses, and the consistency of the mortar joints. In an era where the wall was a vital defensive asset, poor workmanship could have catastrophic consequences, leading to breaches or structural failures that could endanger entire garrisons. While historical accounts sometimes mention harsh punishments for substandard work, the underlying motivation was to ensure that every section of the wall met the demanding standards required for its strategic purpose, known as builder's marks or brick stamps, which indicate the name of the kill, the supervisor, or even the work team responsible for that particular batch of bricks or section of the wall. These marks served as a form of accountability, a tangible signature of the individuals who contributed to the immense project, binding them to the quality of their work. Ultimately, the rhythm of bricklaying was a mesmerizing blend of repetition and precision, a micro-act contributing to a macro-monument. Each tap off the trowel, each perfectly laid brick, was a tiny beat in the grand symphony of construction that spanned centuries and stretched for thousands of miles. It was a hypnotic view, indeed, to imagine the endless procession of masons, their hands moving with practiced grace, laying brick after brick, course after course, slowly but inexorably extending the wall across the vast and varied landscape. Every single brick, every single stone, laid with such care and intention, became more than just a building block. It became a silent, enduring testament to the human spirit's capacity for endurance, ingenuity, and unwavering dedication. A physical manifestation of an empire's will, rising from the earth, one patient rhythmic movement at a time. The simple act of laying a brick, multiplied by millions, by thousands of days, by generations of builders, culminated in the most extensive and awe-inspiring structure ever conceived by human hands. We have spoken of the rhythmic laying of bricks, of the steady, measured hand of the mason, transforming countless individual units into a cohesive, unyielding barrier. Each brick, a testament to precision and dedication, contributed to a structure of almost two-dimensional scale. But as we follow the winding path of the Great Wall, we encounter sections where the challenges escalated dramatically, where the materials were no longer the manageable hand-sized bricks, but titanic slabs of stone. Massive blocks weighing many hundreds, even thousands of pounds. These were the true behemoths of the wall, the foundation stones, the cornerstones, the lintels over gateways, and the monumental steps that traverse treacherous mountain passes. And their presence poses a profound question. How, in an age without advanced machinery, without diesel engines or towering cranes, did the builders of the Great Wall hoist and position these gargantuan stones, often in locations that defy belief, clinging to sheer cliffs or cresting razorback ridges? It was an act of engineering and empire, a monumental ballet of human will, ingenuity, and brute force. The logistics involved in moving these colossal elements from the earth, where they lay dormant to their final resting place within the wall, were nothing short of staggering. A testament to an organizational prowess that matched the architectural ambition. Imagine, for a moment, the scene. Far below the proposed line of the wall, perhaps in a distant valley, lies a quarry. It's not a modern, industrialized quarry, but one carved into the very face of a mountain. Often with only the most basic tools, hammers, wedges, chisels, the stone was not simply cut. It was wrestled from the earth. Miners would seek out natural fault lines, or painstakingly chip away at the rock face, sometimes employing a technique where wooden wedges were driven into crevices, then saturated with water. As the wood absorbed the moisture, it would swell, exerting immense pressure until the rock fractured with a groan that echoed through the valleys. Once a suitable block was separated, the real ordeal began. Consider the sheer weight. A single cubic meter of granite, a common material used in the wall, weighs roughly 2.7 tons. Even a modest block, say 1 meter by half a meter by half a meter, would weigh over 1,300 kilograms, almost 3,000 pounds. To move such a mass was to mobilize dozens, sometimes hundreds of individuals. This was not a task for an individual, nor even a small team. This was a collective endeavor, a symphony of coordinated effort and strain. The initial journey from the quarry was often the most perilous. Rough-hewn tracks cleared by hand, snaked through dense forests, across rocky plains, or down steep gradients. The primary method for horizontal transport involved a combination of human muscle and simple mechanical principles. Envision teams of laborers, their shoulders hunched, backs straining, pulling immense sledges. These sledges were essentially robust wooden platforms, often greased with animal fat or wet clay to reduce friction, upon which the massive stones were loaded. Beneath these sledges, a rolling track of log tree trunks, meticulously debarked, and smooth would be laid out. As the sledge moved forward, the logs at the rear would be continually picked up and repositioned at the front, creating a perpetual, albeit slow, conveyor belt of rolling effort. The sounds would have been immense. The rhythmic grunts of the laborers, the creak and groan of straining ropes woven from hemp or bamboo fiber, the dull thud of logs being repositioned, the shouted commands of foremen, their voices cutting through the air to synchronize the immense effort. Each pull, each shift of weight, was a test of endurance, a battle against the unyielding inertia of the stone and the unforgiving resistance of the earth. But the terrain of the Great Wall was rarely flat or forgiving. It traversed the most formidable landscapes China had to offer. Precipitous mountain ranges, deep river valleys, desolate deserts, and windswept plateaus. Moving stones across plains was art enough. But moving them up a mountain, often to altitudes of thousands of feet, presented a challenge of a wholly different magnitude. This is where the ingenuity of ancient Chinese engineering truly shone. One of the most common and effective methods for moving massive stones uphill was the construction of earthen ramps. Picture a gradually sloping incline, meticulously built from compacted earth, rubble, and even temporary timber structures, leading directly to the intended placement point on the wall. These ramps could be incredibly long, sometimes stretching for miles, designed to reduce the gradient to a manageable slope. The stones would then be hauled up these ramps using the same combination of sledges, rollers, and an immense number of human pullers, often augmented by draft animals like oxen, particularly on less steep sections. The sheer volume of material and labor required just to build and then dismantle these temporary ramps was enormous, sometimes rivaling the effort of building the wall itself. Once a stone reached its general vicinity, the challenges shifted from horizontal transport to vertical placement and precise positioning. Here, the principles of leverage became paramount. Simple yet immensely powerful, wooden levers, often fashioned from sturdy tree trunks, were the primary tools for lifting, pivoting, and nudging the colossal blocks into their exact positions. Imagine a team of men working in unison, one end of a thick timber wedged beneath a massive stone. The other end, balanced on a fulcrum, perhaps a smaller stone or a specially placed log. With synchronized pushes, the stone would slowly, agonizingly be lifted by mere inches, allowing smaller stones or shims to be inserted beneath it, gradually raising it to the desired height. It was a slow dance of controlled power, requiring immense coordination and a deep understanding of physics. To raise stones to significant heights for watchtowers or higher courses of the wall, scaffolding was essential. Unlike modern metal scaffolding, these ancient structures were masterpieces of timber construction. Matiform stout logs and bamboo poles, lashed together with ropes, they rose, sometimes several stories high. These platforms not only allowed workers to access the higher sections of the wall, but also served as elevated bases for the intricate network of ropes and pulleys used for lifting. Pulleys, while perhaps not as complex as some later inventions, were crucial, using simple systems of ropes threaded through grooved wheels or around strong wooden posts. The mechanical advantage gained by pulleys allowed fewer people to exert force, could lift immense weights, albeit over a greater distance of rope pull. Picture a team of men pulling on a rope, their collective strength magnified by a system of pulleys, slowly hauling a massive stone upwards, foot by agonizing foot towards its final resting place. The ropes, groaning under the strain, would be meticulously inspected for fraying. For a single failure could lead to catastrophic consequences. The integration of these techniques, ramps, rollers, levers, ropes, and scaffolding, required an exceptional level of organization and leadership. Foremen, often experienced masons or engineers, acted as conductors of this human orchestra. Their keen eyes assessed the terrain, calculated the forces required, and directed the efforts of hundreds of men. They understood the nuances of gradient, the braking strength of a rope, and the strategic placement of a fulcrum. Their leadership was not just about issuing commands, but about inspiring cooperation, maintaining morale, and problem-solving on the fly as unexpected challenges invariably arose. Consider the immense human cost associated with these efforts. The Great Wall was built over centuries by millions of laborers, soldiers, peasants, convicts. The work was brutal, the conditions often extreme. From the scorching heat of summer, the biting winds and freezing temperatures of winter, construction continued, driven by imperial decree. Accidents were common. A slipped rope, a crumbling ramp, a miscalculated lift could mean injury or death. So the very earth beneath their feet, carvadoned, shaped to serve the wall, also claimed many lives. Yet, despite the inherent dangers and the sheer physical toll, the work progressed. Each block of stone wrested from the earth, transported across impossible distances, and meticulously positioned, became a symbol of this collective struggle. The smooth, weather-worn faces of these ancient stones, now bleached by centuries of sun and wind, whisper stories of immense effort, of hands calloused and backs bent. They tell of the ingenuity of a people who, faced with the monumental task of securing their empire, found ways to move mountains, quite literally. The process was rarely hurried. Speed was often sacrificed for safety and precision. Each major stone had to be perfectly seated, interlocking with its neighbors, forming a sturdy, impenetrable barrier. Once a stone was lifted and placed, it wasn't just dropped into position. It was meticulously nudged, adjusted, and mortared into place, sometimes requiring further small lifts and pivots until it sat perfectly flush, contributing to the structural integrity of the wall. The mortar, a blend of lime, sand, and sometimes sticky rice or glutinous millet, would then be carefully packed into the joints, binding the stone to the brick sand, other stones around it, sealing it against the elements and the passage of time. Let us envision a specific scenario. Moving a massive stone block up a particularly steep and rocky mountainside. The quarry might be miles away at the base of Thurange. First, a path must be cleared. Trees felled, boulders moved, a rough track established. Then the block is loaded onto a sledge. Perhaps dozens of men grasp thick ropes, their feet digging into the loose earth, their bows slinting forward against the harnesses across their chests. Ahead of them, a smaller team constantly lays down rollers, while behind, others retrieve the used ones. The foreman walks alongside, his eyes fixed on the stone, his voice a steady rhythm, encouragement, and instruction. As the slope steepens, the number of men required multiplies. On some sections, the gradient was so severe that zigzagging paths or a series of shorter ramps were necessary. For truly vertical ascents where even a ramp was impractical, the only recourse was sheer lifting. Here teams would construct towering wooden derricks, primitive cranes often anchored securely into the bedrock. With an intricate system of ropes and pulleys, using human and sometimes animal power, the stones would be slowly winched upwards, swinging precariously in the air before being guided into place. The creaking of the timber, the tautness of the ropes, the shared breath of the men as they strained together, these wareth sounds of an empire being built, one immense stone at a time. Consider the climatic conditions. The freezing winters, where hands would numb and ropes would stiffen, making the work even more treacherous. The sweltering summers where dehydration and heatstroke were constant threats, yet the work continued. The vision of a continuous defensive line, stretching across the vast northern frontier, propelled these endeavors forward. Each great stone, once a part of the inert earth, wastelands formed into a a silent guardian against invasion. The sheer volume of material transport and placement also speaks volumes about the incredible logistical capabilities of the various dynasties involved in the wall's construction. This wasn't a short-term project. It spanned centuries, maintaining a workforce of thousands, sometimes hundreds of thousands, in often remote and hostile environments, required an unparalleled system of supply. Food, water, tools, raw materials for ropes and scaffolding, replacement parts, and even medical provisions had to be continuously transported to the construction sites. This intricate network of supply lines, stretching from distant agricultural centers to the most isolated mountain peaks, was itself a logistical marvel underpinning the entire construction effort. The placement of these great stones was not merely about brute strength. It was an art. Each stone had a purpose, often serving as a foundation for a watchtower, the sturdy base of a gateway, or the critical load-bearing element of a wall section traversing a particularly vulnerable point. Their irregular shapes often meant they had to be carefully selected, sometimes even roughly dressed on site. To fit together snugly, minimizing gaps and maximizing stability, the masons who oversaw this work possessed an intuitive understanding of structural mechanics, knowing how to distribute weight, how to interlock irregular shapes to create an unyielding bond, and how to use the natural strengths of the stone to their advantage. Even today, when we stand before these ancient sections of the Great Wall, particular life built with these massive stone foundations and courses, we cannot help but feel a profound sense of awe. The sheer scale, the incredible effort, the ingenious solutions to seemingly insurmountable problems, all speak to the enduring spirit of human endeavor. These great stones are not just inert rock. They are tangible echoes of a bygone era, silent witnesses to the will of emperors, the genius of engineers, and the relentless labor of countless individuals. From the quiet, focused rhythm of the bricklayer, we shift our gaze to the collective, straining effort of hundreds, moving mountains, literally. But the Great Wall, in its endless brickwork, also embodies the titanic struggle of hauling and placing these great stones. A fundamental engineering challenge that was met with a combination of unwavering determination and profound ingenuity. It is a story etched not just in the mortar and the bricks, but in the very heart of these massive, unyielding stones, each one a testament to an empire built on human will. But how, you might ask, did this immense human will, this collective determination to build, translate into the shaping and lifting of those monumental stones, into the laying of countless bricks and the construction of such an enduring marvel? The answer, least note, in futuristic technology, but in the ingenious application of surprisingly simple tools and techniques honed over centuries of building. It is a testament to the profound understanding of physics, the meticulous observation of nature, and the sheer relentless power of organized human labor. As we shift our focus now from the colossal effort of hauling and placing great stones, we turn our attention to the more granular, yet equally vital aspects of the ancient builder's craft. The tools and techniques were, in their essence, simple, yet extraordinarily effective. Imagine yourself standing on a construction site, perhaps high on a mountain pass or deep in a valley, thousands of years ago. The air is thick with the dust of freshly broken stone and drying mortar. The sounds are a symphony of human effort, the rhythmic clang of hammer on chisel, the creak of timber under strain, the shouted commands of overseers, and the grunts of men moving heavy loads. Every one of these sounds, every particle of dust, every calloused hand tells a story of the ingenuity that allowed an empire to etch its will in stone and earth. Let us begin at the very source of the wall itself, the quarry. Before a single stone could be laid, it first had to be freed from the embrace of the earth. The primary tools here were deceptively basic, yet their application required immense skill and strength. Picks, often tipped with iron or hardened bronze, were used to chip away at softer rock and to outline the desired sections of harder stone. Hammers, heavy and robust, were wielded to drive wedges and to break off smaller, more manageable pieces. But for the truly colossal blocks, a different technique was often employed, one that harnessed the power of nature itself. Builders would look for natural fault lines in the rock, or carefully carve channels into the stone. Into these channels, they would insert wooden wedges, often made from oak or other dense, resilient timber. Once seen place, water would be poured over these wedges. As the wood slowly absorbed the water, it would swell with an almost imperceptible, yet irresistible force. Over hours or even days, this expansion would exert tremendous pressure on the rock, until, with a deep, resonant crack, the stone would split along its natural grain or the line of the wedges. This was a patient, almost meditative process, reliant on observation and a deep understanding of the materials. It was a technique that transformed a simple piece of wood and a few drops of water into a force capable of rending mountains. Another equally impressive method for splitting larger stones involved the controlled application of fire and water. Imagine a colossal boulder, stubborn and unyielding. Builders would build roaring fires directly on its surface, heating the rock intensely for hours, sometimes even days. The stone would glow, expanding under the extreme heat. Then, with a sudden, dramatic flourish, cold water would be doused over the superheated surface. The rapid contraction caused by the sudden cooling would create immense internal stresses, often resulting in spectacular cracks and fissures, allowing the stone to be broken into more manageable pieces. This was a dangerous, dramatic technique, requiring careful handling of bath, fire, and water. But it offered a powerful means to overcome the most stubborn geological obstacles. Once the stone was freed from its bedrock prison, it still needed to be prepared for its journey and its ultimate placement. This initial shaping or dressing often occurred directly at the quarry site. Why move an impossibly heavy, irregularly shaped mass when you can lighten and refine it where it lies? Here, a different set of hammers and chisels came into play. Heavy sledgehammers would be used to break off large, unwanted protrusions, their blows ringing out across the quarry like distant thunder. Finer, iron-tipped chisels, guided by the skilled hands of masons, would then begin to smooth and shape its surfaces, creating rough but functional faces that would allow the stones to fit together more snugly. The constant clink-clink-clink of metal on stone, a steady hypnotic rhythm, was the soundtrack to this painstaking process. Each chip of stone a step closer to the final form. After the quarrying and initial dressing, the monumental task of transportation began, especially for those truly massive foundation stones. How do you move a multi-ton slab of rock, sometimes for miles over rugged terrain, without the aid of modern machinery? The answer lay in the principles of leverage, friction, and an unparalleled command of human organization. Rollers were fundamental. Simple, sturdy logs, cut from local timber, would be placed beneath the stone. With long levers-thick tree trunks used as pry bars, workers would slowly, painstakingly lift one end of the stone, allowing the rollers to be slid underneath. Then, hundreds of soft men, sometimes oxen or mules, would pull on thick ropes, their muscles straining, their collective grunts echoing. As the stone moved forward, the rollers from behind would be retrieved and placed at the front in an endless cyclical ballad of movement. It was a slow, arduous process. Each inch gained a victory, each mile a testament to enduring patience and coordinated effort. Imagine the sheer concentration, the perfectly timed movements, the constant vigilance to prevent the immense weight from shifting dangerously. The very ground beneath their feet would rumble as these behemoths slowly crawled across the landscape. For softer or uneven terrain where rollers might sink, sledges were employed. These were essentially large, heavy wooden platforms, sometimes with runners, on which the stones were loaded. Again, ropes and immense human strength were the primary mode of force. Teams of hundreds, sometimes thousands, would pull, their feet sinking into the earth, their shoulders bowed. It was a brutal test of endurance, often requiring the construction of temporary paths and leveling of ground. To even allow for the passage of these immense loads, the air would be filled with the sound of snapping ropes, the creaking of wood, and the synchronized shouts and chants used to maintain rhythm and morale. Ramps were another indispensable tool, not just for moving stones horizontally, but crucially for lifting them vertically. For the highest sections of the wall, or for raising heavy stones into watchtowers, massive earthen ramps would constructed alongside the wall itself. These ramps, sometimes extending for hundreds of meters and rising gradually to the desired height, allowed workers to drag or roll stones upwards, slowly raising them course by course. As the wall grew taller, the ramp's wall would be extended, always keeping pace with the rising masonry. Once a section of the wall was complete, the ramp would be meticulously dismantled, its earth and stones sometimes repurposed for the next section of construction. This was an astonishing feat of temporary engineering, requiring as much labor and planning as the wall itself. Once a stone or brick reached its designated position, the final stages of placement and masonry came into play. Here, the tools might seem the most familiar, yet their effectiveness was refined to an art form. The plumb line was an ancient builder's most trusted friend. A simple weighted string, it provided an absolute vertical reference, ensuring that walls rose straight and true. Imagine a master mason, his brow furrowed in concentration, holding the plumb bob suspended against the rough-hewn stone, his eyes tracing the perfect unwavering line. This simple tool was the guarantor of structural integrity, a silent arbiter of precision, equally vital where levels. While not as sophisticated as modern spirit levels, ancient builders employed ingenious methods to ensure horizontal accuracy. Water levels, essentially open troughs of water, provided a perfectly flat reference plane. A more common and portable tool was the A-frame level. This was a wooden-shaped frame with a plumb line suspended from its apex. When the plumb bob hung directly over a mark at the center of the crossbar, the base of the A was perfectly level. These tools, simple in design, demanded careful handling and keen eyesight. But they allowed builders to lay courses of stone and brick with remarkable uniformity, creating the stable, flat surfaces necessary for the wall's immense length. Measuring tools were similarly rudimentary yet effective. Simple ropes, knotted at precise intervals, or wooden measuring sticks, often calibrated to specific imperial units, ensured consistency in the dimensions of the wall, the spacing of watchtowers, and the size of individual bricks. These weren't just practical tools, they were the means by which a unified vision, dictated by architects and engineers hundreds of miles away, could be translated into tangible form on diverse and challenging landscapes. For the actual laying of bricks and smaller stones, trowels were essential. Early trowels might have been simple, flattened pieces of wood or metal used to scoop and spread the vital lime mortar. The mortar, often a mixture of slaked lime, sand, and sometimes sticky rice flour for added strength, was the binding agent that held the entire structure together. The application of mortar was a skill in itself, requiring an understanding of consistency, drying times, and how to create a strong, durable bond between irregular surfaces. A good mason knew exactly how much mortar to apply, how to press the brick or stone firmly into place, and how to tool the joints to shed water effectively. Hammers, of course, were omnipresent. Beyond the heavy sledges of the quarry, masons used smaller, more refined hammers for setting bricks, tapping them gently into place to achieve the perfect alignment. They also used setting hammers for stone, their skilled blows ensuring a snug fit without damaging the carefully dressed surfaces. Chisels continued to play a role too, even on the wall itself. For any final adjustments or dressing needed to accommodate a particularly stubborn piece of stone, the precise, rhythmic tap-tap of a mason's hammer, a sound of creation, would have been a constant presence on the wall. Scaffolding, though often temporary, was another critical tool in the ancient builder's arsenal. It's primarily constructed from sturdy timber or in regions where it was abundant, resilient bamboo. These temporary structures allowed workers to reach the ever-growing heights of the wall. Imagine forests of wooden poles lashed together with ropes and bamboo strips, forming intricate platforms that hugged the rising masonry. These scaffolds had to be strong enough to bear the weight of men, tools, and materials, yet flexible enough to be easily extended and dismantled. They were a dynamic, ever-changing part of the construction landscape, a vertical extension of the human effort. While elaborate cranes with complex pulley systems were rare for truly massive lifts, simpler hoisting mechanisms were certainly in use. A-frame structures, essentially two robust timbers, lashed together at the top, forming an A shape, could be erected. From the apex, ropes could be run through simple wooden sheaves, allowing several men to lift smaller stones or bundles of bricks with greater mechanical advantage than brute strength alone. For larger stones, the earth ramp remained the primary method, But for the countless bricks and smaller building blocks, these rudimentary hoists significantly imp efficiency and reduced strain. The creaking of ropes, the groaning of stressed timber, the coordinated shouts of heave. These were the sounds of gravity being defied, inch by laborious inch. It is easy, perhaps, to look back at these simple tools and techniques and underestimate the profound ingenuity they represent. But to do so would be a mistake. The true genius of the ancient Chinese builders lay not in the complexity of their implements, but in their deep understanding of fundamental principles. They understood leverage implicitly, applying it with unmatched skill to move objects many times their own weight. They grasped the concepts of friction, knowing when to minimize it with rollers and when to maximize it for stability. They mastered the properties of materials, the swelling of wood, the expansive force of freezing water, the cohesive strength of lime mortar, the resilience of timber and bamboo. More than just tools, these were extensions of human will and intellect. Each hammer, each chisel, each rope, each carefully constructed ramp was a physical manifestation of a problem solved, a challenge overcome. The collective knowledge passed down through generations, refined by observation and experimentation, allowed them to adapt their methods to the wildly diverse terrains the wall traversed. From the scorching deserts of the west to the icy mountains of the north, the organization of labor itself was a technique of immense sophistication. Thousands, sometimes hundreds of thousands of workers had to be coordinated, fed, housed, directed across vast distances. Military discipline, agricultural calendars, and a clear hierarchy of command were all essential tools in managing such an epic undertaking. Foremen, master masons, and engineers ensured that supplies flowed, tasks were assigned, and quality was maintained, all while adapting to the unpredictable realities of weather, terrain, and human exhaustion. When we look upon the endless brickwork of the Great Wall today, it is not merely the bricks and stones we see, it is the echo of the picks that first struck the rock, the creak of the wooden wedges, the rumble of stones on rollers, the rhythmic clang of chisel on stone. It is the imagined sight of thousands of hands spooling on ropes, the sound of their synchronized chants, the wisdom encoded in the plumb line and the level. It is a monument to human ingenuity, born not from advanced machinery, but from the elegant simplicity of mind over matter, a testament to what can be achieved when determination meets a profound understanding of the world. Every single element, from the smallest chisel mark to the largest foundation stone, tells a part of this incredible story of simple tools, effective techniques, and unyielding human spirit. And it is this unyielding spirit, this relentless push forward against all odds, that truly defines the final, most breathtaking aspect of the Great Wall, the sheer hypnotic spectacle of its unceasing progress. For centuries, across dynasties and generations, the work never truly stopped. It was a monumental undertaking, not measured in years or even decades, but in lifetimes, in the very fabric of Chinese history itself. To truly grasp the essence of the Great Wall, we must move beyond the individual acts of construction and begin to perceive the vast, flowing river of effort that carved it into existence. A river that seemed to have no beginning and no end. Imagine, if you will, standing at a vantage point high above the land, looking out over a landscape that stretches to the horizon in every direction. At first, you might see nothing but rolling hills, jagged mountains, and vast plains. But then, your eyes would catch it, a thin, winding line, snaking its way over peaks and through valleys. A ribbon of stone and earth that seems to pulsate with an almost imperceptible energy. This is the Great Wall in its raw, unadulterated form, an act of pure, sustained will made manifest. It is a testament to an unyielding progress that, even today, retains a mesmerizing quality. This progress wasn't a sudden burst of activity, like the raising of a single grand cathedral. It was a slow, deliberate, almost geological accumulation of effort. Each day, each week, each month, the wall grew a little longer, a little taller, a little stronger. It was the rhythm of a heartbeat, steady and unwavering, sustained over an impossible span of time. We speak of building the Great Wall, as if it were a single event. But it was, in truth, an ongoing process, a continuous dialogue between humanity and the landscape, a never-ending narrative etched in stone. Think of the sheer magnitude of the commitment. Dynasties rose and fell, empires expanded and contracted, but the work on the wall, in one form or another, persisted. It became a legacy passed down, not just through royal decrees, but through the calloused hands of fathers to sons. Through the collective memory of villages whose very existence revolved around its construction. The knowledge of how to cut stone, how to mix mortar, how to haul a heavy beam, these were not just skills, they were inherited traditions, fundamental to the identity of countless individuals whose lives were inextricably linked to the wall's inexorable march across the land. This unyielding progress was driven by a multitude of factors, each contributing to its hypnotic core. There was the constant threat from the north, a ceaseless pressure that demanded an equally ceaseless response. There was the strategic vision of emperors who understood that a unified defense required a unified barrier. And perhaps most profoundly, there was the deep human capacity for perseverance. The innate drive to overcome monumental obstacles, to leave an indelible mark on the world. This wasn't merely a construction project. It was an act of national determination, a physical embodiment of a civilization's resolve. Consider the daily grind, the repetitive actions that, when aggregated, formed this world wonder. Imagine 1,000 different work sites, spread across hundreds, even thousands of miles. At each site, the same cycle would repeat day after day, year after year. The quarryman would chip away at the rock face, their hammers ringing out a constant percussive symphony against the raw earth. The earth movers would shovel soil, fill baskets, and tamp down layers, their movements a synchronized dance of muscle and sweat. The masons, with meticulous care, would lay brick after brick, stone after stone, following ancient patterns and precise measurements, their hands moving with the practiced efficiency of generations. The sounds of this progress would have been a constant presence. The rhythmic thud of ramming tools compacting earth, the scraped sheck of shovels against rock, the shouted commands of foremen carried on the wind, the low, guttural chants of men hauling immense stones up treacherous slopes. Overlaying all of this would be the subtle, ceaseless hum of human endeavor, the collective breath of thousands of people working in unison, their individual efforts blending into a single, overwhelming force. These weren't the cacophonous sounds of modern machinery, but the organic, deeply human sounds of labor. Each one a tiny increment of the wall's slow, steady march. The sights. The endless line of human bodies, silhouetted against the rising and setting sun, moving like a living river along the spine of the mountains. Plumes of dust rising from quarries, painting the sky with a hazy veil. The fires flickering at night, marking sprawling encampments where workers rested, only to rise again before dawn to resume their Sisyphean task. The sight of the wall itself, ever growing, ever extending. A man-made geological feature slowly asserting its dominance over the natural world. From a distance it must have appeared like a living creature, slowly stretching its immense body across the vast landscape. The very nature of the terrain itself contributed to this hypnotic sense of unending effort. The Great Wall doesn't follow a straight, easy path. It is a monument to defiance, twisting and turning, climbing impossible gradients, plunging into deep ravines, and then re-emerging on distant ridges. Each curve, each ascent, each descent represented a new challenge, a new problem to solve, a new section to meticulously plan and execute. The builders didn't shy away from the most daunting landscapes. They embraced them, forcing the wall to conform to the contours of the earth, yet simultaneously imposing their will upon it. This constant negotiation with nature made the progress feel organic, almost like the growth of a root system, seeking out new ground to conquer. Imagine the view from one of the watchtowers high up on a mountain pass. You would see the wall stretching away in both directions, an almost dizzying perspective of repetition and scale. Tower after tower, battlement after battlement, all following the same fundamental design, yet each subtly unique due to the variations of the terrain and the hands that built it. It's a fractal beauty, where the pattern repeats at different scales, drawing your eye further and further into the distance, suggesting an infinity of identical yet distinct segments. This visual rhythm creates a powerful sense of timelessness, a feeling that this structure has always been here and always will be. Even the materials themselves speak to this unyielding progress. Millions upon millions of bricks, each one shaped from clay, fired in kilns, and then transported to its final resting place. Billions of stones, quarried, dressed, and carefully positioned. And the mortar, a humble mix of lime and sand, yet binding all these elements together with an unbreakable grip. Each individual component, simple in itself, became part of a larger, immensely complex whole, a monumental tessellation of human effort and natural resources. The sheer volume of these materials, extracted and moved, is almost beyond comprehension, forcing us to confront the scale of human impact on the planet, even in ancient times. The Great Wall, in its unyielding progress, was also a masterclass in adaptation. As new threats emerged, or as technologies improved, sections of the wall were modified, rebuilt, or expanded. It was not a static entity, but a dynamic one, constantly evolving to meet the changing needs of the empire. This meant that the work was truly endless, a continuous cycle of construction, repair, and innovation. A watchtower built in one century might be reinforced in the next. A crumbling section might be entirely rebuilt, or new segments added to extend its reach. This constant state of flux, ironically, only amplifies the sense of its unyielding nature, as if the wall itself were a living, breathing organism, continually repairing and growing. There's a profound lesson in this hypnotic view of the endless wall. It teaches us about the power of sustained effort, about what can be achieved not through sudden brilliance, but through methodical, relentless application. It speaks to the human capacity for long-term vision, for undertaking projects that will not be completed within a single lifetime, perhaps not even within many. It demands a different understanding of time, one that stretches beyond individual experience and embraces the sweep of generations. When we consider the Great Wall as an unyielding, ongoing project, it becomes more than just a defensive barrier. It transforms into a symbol of continuity, of a civilization's enduring commitment to its own survival and prosperity. It embodies the deep-seated human need to create, to build, to impose order upon chaos, to protect what is cherished. Its very existence, stretching further than the eye can see, whispering tales of countless hands and untold years, instills a sense of awe, a quiet reverence for the sheer, unrelenting power of human collective will. And so, as you gaze upon the images of the Great Wall, winding its way across rugged landscapes, let your mind drift beyond the static image. Allow yourself to be transported back in time, to hear the echoes of the picks and chisels, to feel the dust on the wind, to witness the endless procession of workers, each one a vital cog in this immense ancient machine. See the wall not just as a finished structure, but as a perpetual process, a testament to an unyielding progress that, even now, continues to inspire and humble us with its scale, its duration, and its truly hypnotic view. It reminds us that some of the greatest achievements of humanity are not born of fleeting genius, but of the slow, steady, and utterly relentless pursuit of a singular monumental vision. Imagine the endless chain, a scoop of sandy mortar, wet and cool, scraped from the basin. The grunt as a rough-hewn stone is lifted, its edges biting into calloused palms, its weight a familiar burden, a slow, steady shuffle to the waiting gap. The careful placement, a slight shift, a tap of the wooden mallet, asterisk, thud, 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 asterisk, settling it into its permanent home. And then, the hands reach out again for the next stone, the next scoop of mortar. This was not a rush, but a sustained, deliberate dance. The sun beat down on their simple, earth-toned tunics, on straw hats shadowing faces etched with years of sun and wind. But their gaze remained fixed, their movements synchronized. Young and old, their individual identities blurred into the vast collective purpose. Their strong, resilient bodies, often barefooted, moved with a practiced grace that belied the arduous nature of their task. The rhythmic scraping of the shovel, the lifting of the stone, the gentle placement, the satisfying thud of the mallet, it became a heartbeat, a pulse echoing through the mountains, sound that, even now through the centuries, invites us to slow our own breath, to find a profound peace in the relentless, quiet work of ages. It is in this endless repetition, in this humble, powerful rhythm, that the wall truly lives, a monument not just of stone, but of countless moments of quiet, determined effort, this silent, unyielding commitment to a shared vision, performed day after day, year after year, until the task became instinct, the rhythm, a lullaby. I'm lullaby. And as you allow your mind to drift back to that ancient, persistent rhythm, you might find your own thoughts settling, your own breath deepening, finding a quiet stillness within the very heart of this immense and enduring human creation, beckoning us to simply observe and to rest. Thank you for joining me on this journey into the quiet power of the Great Wall. If you found a moment of peace and wonder in this story, please consider subscribing to Delight Show for more immersive tales. And perhaps find your next moment of reflection by exploring another one of our videos. Till next time, find calm in the rhythm of the world.